Okay, in this video we're going to talk about properties of exponents. So I want to talk about a to the n. Okay, a is the base, which is a real number. Sometimes we represent a real number as this pretty little r here. Okay, so if I write that little r, that just means it's a real number. Okay, the n up here is an exponent. Tells us how many a's there are. Okay, the natural number is our exponent, and we're just going to represent a natural number by that cursor or that script n there. Okay, so what does a to the n mean? So a to the n means that I multiply a times a times a dot 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 n times. So how many a's are there? There are n of them. Okay, so to give you an example, say I've got 2 times 2 times 2 times 2 times 2. You know, that's a lot to write out. So mathematicians are lazy. They came up with this shorthand. So instead of writing this out 5 times, I write 2, which is the base, raised to the, well, how many 2's are there? There's 5 of them, raised to the 2. All right, so if we go into our little calculator and type in 2, and I have my little exponent on the side there by the right above the divide, and I hit the 5 and I hit enter, that's 32. Okay, this is equal to 32 here. Now, got to be careful with negatives. Very tricky here. So if you see -3 squared, okay, the negative is not in the parentheses. That's a different problem than -3 quantity squared. Okay, so how this is treated, we got to think about order of operations. Okay, order of operations. You ever hear of PEMDAS? Please excuse my dear Aunt Sally, right? What does it stand for? Parentheses, exponents, multiplication, division, addition, subtraction. Okay? So that's the order in which we do things. So when I look at this, I've got my exponent first here. So how's this going to work? Well, having a negative out front is like having a -1 multiplied by what we have left here. That's 3 squared. So this is equal to -1. And then how many 3's do I have? Exponent tells me how many there are. There's 2 of them. So it's negative times a positive makes a -9 there. Okay? So how's that different than this one here? This one here, the parentheses is around the base. So what this says is I write the base how many times? Twice. So I do -3 times -3. And what is negative times a negative? 2 negatives cancel to make a +9. Okay, so those are different answers. So very common mistake. Students will think that -3 squared equals +9, but in reality, -3 squared equals -9. Okay, so be careful. Don't let that trick you up. Very common mistake. Okay. So let's try to do some more multiplication. See if we can come up with some rules. X cubed times x squared. If you're ever in doubt on what to do, best thing to do is when in doubt, write it out. What does that mean? X cubed tells me that I have 3 x's, so I have x, 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 okay? X squared tells me I have 2 x's, so I have x times x. Now, if I've got 1, 2, 3, 4, 5 x's, instead of writing out x, 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 right? That's kind of boring, right? What we're going to do instead is we're going to write out x to the, how many x's are there? 1, 2, 3, 4, 5. Okay, x to the 5th. Okay? So, we can come up with a rule here. And so the rule goes with these properties of exponents. Okay? So property number 1 is if I have a to the n times a to the m, same base, I add the exponents. I add the exponents. You think about it, I have 3 here, and I have 2 there. 3 plus 2 gets me 5. Okay, so that's what's going on there. So a shortcut method, if I have the same base, they're both base x, then I have 3 plus 2 gives me x to the 5th. So kind of a shortcut for you. These are shortcuts. Okay, so they're meant to help you do your homework quicker. So use them. Don't waste time. All right, y to the 5th divided by y cubed. Once again, when in doubt, write it out. So how many y's do I have in the numerator? I've got 5. Why am I taking this class, right? Divided by how many y's in the denominator? Y here. Okay. When I look at this, I see that y cancels with this y here. This y is going to cancel with that y. And then that y cancels with that y there. And so what am I left with? I'm left with y in the numerator. What about in the denominator? Do I have 0? No. I cancel here, and I'm left with a 1. Okay? You're left with that 1 factor. Think of it kind of like a placeholder. So y times y is y squared. So how could I use some rule kind of like I did up here with my pluses to have a rule here? I've got 5 and I got 3 and I end up with 2. Well, how can I do that? I can do that via subtraction. So rule number 2. Rule number 2, an divided by am. So let's see, it looks like I took the top and I minus the bottom to get the 2, right? So what is this equal to? It's a raised to the n, the top, right? Minus the denominator power m, right there. Okay, so there's another rule. So we got 2 rules. Okay, let's see if we can do some more rules. Let's do x squared over x cubed. Now, how many x's do I have up top? I got 2 up top, right? And I got 3 down low. Who wins in the fight here? The fight with 3 wins by how many? 1 left over. So what do I have? I have 1 over x. But if I used my rule here, I'd have x squared divided by x cubed equals, what's the rule say? X to the 2 minus 3, right? When I do this, I get x to the negative 1. Uh-oh. So, we do not want to have a negative here in the exponent, right? We're trying to avoid negatives. Okay, so if we're going to avoid negatives, that means we got to figure out, what is this equivalent to? Well, what do I know that this equals right here? This is the same thing as 1 over x. So I think I just came up with a new rule. Okay, so another rule here, rule number 3. If I have x to the negative n, this is 1 over x to the n. Okay, so there's another rule for you right there. Now, this is true for x not equal to 0. If x equals 0, can't divide by 0, okay? And n is an integer. Now another fancy script for integer is z. I don't typically do that, but just in case you ever did see a z, that means integer there. Okay? All right, let's try another one. Another exponent property. Let's take y divided by y. Okay, how many y's up top? 1. How many y's down low? 1. So when I cancel, I get 1 over 1, which equals 1. So what's this telling me? I have 1 y up top and 1 y down low. If I use my rule, I get y 1 minus 1, which is y to the 0. So y to the 0 is equal to 1. So what does this mean? Rule number 4. If I have a to the 0, this equals 1 as long as a is not equal to 0. Because if a equals 0, then I'm dividing by 0. Okay? Excuse me. It would actually be undefined. If you try to type in your calculator 0 raised to the 0 power, that's undefined. Okay? 0 raised to the 0. Oh, well, my calculator is not smart enough to know that, but if you got your 84, it will tell you that you can't do it. Okay. So, lesson here, I raise any number to the 0 except for 0, I'm going to get 1. All right, let's try another one. X squared raised to the 3. X squared raised to the 3. Now, at its core, how I think about this, there's something in here, and I'm going to raise it. I'm going to write it out 3 times. So if I ever see something cubed, that means it's something times that same something. Okay? So if I wrote this out, what's the something inside? It's x squared times x squared times x squared. Okay? Now, how many x squareds are there? Well, you could write this out. You'd have xx, 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 right? How many x's total? There's 6, so that's x to the 6th. Now, that's okay when this number is small, right? But what if you had like x squared and then 3 and then like 300, right? You're not going to write this out 300 times. I mean, that's a little cuckoo for Cocoa Puffs, right? So you don't have a duplicator. Even if you had a duplicator, look how hard that would be, right? So think about having to do that. I mean, that's insane, right? You don't want to do that. So instead of doing that, we need to come up with a trick that's going to help us. Well, how do I get from 2 and 3 to 6? Right? Adding doesn't get it, and subtracting really doesn't get it. But if I multiply 2 times 3, guess what? I do get the 6. So here's the rule. Okay, and so I guess this is rule number 4. If I have something to a power raised to another power, okay, all I do is I multiply the exponents. Okay, multiply your exponents. Okay? So the rule still works even if I've got, something like a times b raised to some n here. Now what's the power inside here? It's 1 and 1. Power to a power, I multiply everything in here. So that's a to the n times b to the n, just like that. Same thing works with division too. A divided by b raised to the n is a to the n over b to the n. Okay, same thing going on there. So those are rules. Hopefully they'll help you out when you're pushing through your examples, okay? So let's try this one. It's 4y cubed z to the 5 raised to the 3, okay? So if I see raised to the 3, that's not too big a deal. I can write that out 3 times. So I'm just going to go ahead and write it out 3 times. Just make sure we're good to go. So I'm going to write it out. I could copy and paste this, but I guess I won't be lazy for this video. Okay. So I've written it out 3 times. Now, when I multiply, I like to multiply my numbers together first. So I've got numbers, those coefficients there in front. 4 times 4 times 4. How many 4s is that? Well, that's 3 4s. So I can write it out as 3 4s like this. That's fine. Now, what about the next part? Y, y, and y. How many y's total? There's y cubed there, y cubed here, and y cubed here. Okay. And then last, I've got z's. So z, z, so z to the 5th, z to the 5th, and z to the 5th there. So what? So what's going to happen? 4 times 4 times 4, multiply that in your calculator, you get 64. You could also write this as 4 cubed, right? Okay. And then what are you going to have? Well, you've got 3 y's, 3 y's, 3 y's, 3, 3, 3. That's 9. So there's 9 of those y's there. So I'm going to put y to the 9. And then last, what do I have? I got 5, 5, 5. That's 15. So z to the 15. So that is one way to get your answer. We can use the rules that make life a little bit better for us. Let's show you how to use the rules to make life a little bit better. So if you want to use the rule, this is how I would use the rule. I'd look in here and I'd say, okay, how many 4s do I have inside here? Well, there's only 1 in there, okay? So what I'm going to do, I'm going to take this 3 on the outside and multiply by this 1 in here, the exponent. So this gives me 4 to the 3. And now I'm going to multiply this 3 by that exponent, 3 here. So that's y to the 3 times 3 is 9. And then last, I'm going to multiply this exponent 3 times that 5 there, and I get 15. So that's z to the 15. So now the only thing we got to do is we got to type in 4 to the 3. And you can do it in your calculator if you don't feel comfortable. So let me clear this. 4 raised to the 3. 64 going on right there. So that's 64. Y to the 9th, z to the 15th. And you got it. Okay, so that's what you're looking for.